Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. Did you know that the longest bridge in the world spans over miles of water, showcasing the incredible innovation and skill behind its construction? I'm your co-host, Rachel Holland, and today I'm speaking with Brianne Kliphardt, an EIT bridge design engineer at AECOM. We're going to talk about bridge design engineering, exploring her career journey, challenges that she's had, and we're going to highlight the exciting job opportunity for a senior bridge engineer. Before we get started, here's a quick word from our sponsor for this episode, PPI, a Kaplan company.
PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
Hey, Brianne, thank you so much for joining us on the podcast today. Can you start us off by telling us a little bit about yourself, and then we can get into what you do on a daily basis?
Okay, of course. I'm Brianne. I'm a bridge engineer at AECOM currently, and I grew up in Central Washington and went to school at Big Bend Community College and WSU, and with a focus on structural engineering all of college. And yeah, I have been working in bridge design ever since I graduated in 2021 with my master's. And yeah, that's a little bit about me.
So on a daily basis, then, you are a bridge engineer. You've been doing it for a handful of years. And what do you do on a daily basis?
So the day-to-day is always interesting. I mean, I feel like I'm always doing something new or different or unique. Typically, it involves calculations. So I'm opening up MathCAD, Excel sheets, and just cranking numbers. Or a lot of days, I'm also trying to develop plans. So marking up plans for CAD to take care of and putting all of that together. Sometimes it's structure layout. Sometimes it's, talking with my team, trying to figure out solutions and stuff like that. And it can always be a little different. Like everything can be different. The calculations can be different every day. Like one day I'll do this calc and it'll be like, oh, this is, we're done. And then the contractor will come back and say, oh, can you look at this? And then I'll be doing a different calculation the next day. And it kind of keeps it interesting that way. So
awesome. For people that so our listeners are not just like bridge people, right? It's more like structural. So a lot of like building structural engineers too. So not all of us, me included, are as familiar with bridge design. So can you explain sort of like what that involves?
Yeah. That is one thing I experienced in college was everything was building design. So when I got into industry and my full-time jobs, it was learning everything new, like learning new standards, just kind of the scale of things is a little different. So the main thing I would say is our clients are a little different, typically, especially with the firms that I've worked for. So usually it's a local.
Like, are they usually cities?
Yeah, cities, counties, states. I mean, occasionally some companies will have private clients that are like looking for a structural engineer, but most commonly in medium to larger firms, it's counties, cities, and stuff like that. So okay. They typically have, each state has their own standards you have to follow. And that is based off of the normal like bridge standards that we follow. So it's like ASCE 7. I haven't touched that in years because I've been working in bridge design. So it is a little bit different, scale, a little different. also we have different types of projects. So sometimes, I think you can relate them back a little bit to buildings, but we have new bridge design, we have replacement projects. So if, a bridge is getting to its service life, you might be replacing that or rehabilitating it. There's also bridge widenings where we're like adding on to an existing bridge, and those can be kind of complicated projects too. So yeah, there's all kinds of different types of projects in bridge design. And yeah, I think other than that, like a lot of the fundamentals are the same. You're doing the same structural calculations. It's just different, sometimes different concepts are being applied, different standards are being applied. And I'd say that's the biggest difference I've noticed.
Okay. What about, you're still a little bit early in your career. And so like, how did you decide to go into bridge design versus building design? Because you said your master's was in structural engineering, right? Not specifically bridges.
Yes, that's right. It's actually a really interesting story, I think. When I was growing up, like I really loved math, and I know every engineer might tell you that, but I mean, I loved math. I was in second grade and I was like getting home from school and forcing like my grandpa or my dad or my uncle to write math problems for me. And they would get so sick of me asking them to write write a problem for me. And so math was a big thing for me. Art was a really big thing for me as well. So I think that's kind of where the civil engineering kind of came into it. But another significant moment in my life was when I was 14 and I was at a friend's house and we were watching Final Destination 5. And in that movie, there is a bridge collapse, and it's based on the North Bay Bridge that collapsed in New York. And so when I was sitting there watching this movie, I was like, well, why did that happen? And basically, ever since then, I just kind of put that together with my math and my art and discovered that civil engineering was for me and that bridge engineering was for me. And yeah, I think every step of the way, every job that I've had, every little task that I do just kind of is a reassurance that like I really love what I do and love bridge design. So
that's awesome. It's funny how like a movie when you're 14 can shape like what you do for your career, right?
Yeah, it was unexpected.
So clearly you're passionate about it. What excites you the most about bridge design? And I mean, I guess structural engineering in general, but specifically bridge design.
Oh, I think there is a lot of different things that I get excited about. For one, you're using these bridges usually. Like if you're working on a project, I can usually, drive by it and say like, oh, like I am working on something that's going to like happen here, or like this new project that's coming here. And it's kind of cool to I think it's fun to kind of say that, but also I think what's also exciting about it is it's kind of, and I think this is more generic, but I feel like the industry is kind of ever changing. Like there's always new testing, there's always new standards being applied and stuff like that, that new solutions that kind of keep like the engineers on their toes. And I really like that about it because it kind of encourages creativity and kind of, even though we've done it before, doesn't mean there's not a better way that we could think up tonight or tomorrow. And you never know.
I was going to say also, I was going to add to that like, I totally agree with you on that because like, even if we do have the best way that we can do something and it's tried and true and we think we know, like, I feel like even then still Mother Nature will throw a kink in there and we'll be like, oh, wait, like we don't know everything there is to know about like seismic stuff and just the ways in which the earth can kind of like throw us for a loop. And then we have to continue to like better our designs and
yes,
all of that.
Yes, I would say one really cool example, which is local for me, is the Tacoma Narrows Bridge that became a National Historic Bridge because of its collapse and how it changed standards after the collapse because of what engineers learned from the failure. I think that is like, it isn't great that it collapsed, but it's really cool of like what we learned after the fact and how people
And that's near where you grew up, right? Is that near where you grew up?
Yeah. So I grew up in Central Washington and this is in Tacoma. So it's on the West Coast, which is where I'm located now.
Yeah. I think every time something like that happens, it's obviously like a catastrophe and like not great, but obviously we have to take those opportunities to learn from them. And then again, like improve our standards, improve our detailing, our practices, our designs, everything. Yeah. What about as you've kind of been moving along in your schooling and your career, did you have any mentors or like role models who you feel like played a significant part in you becoming an engineer?
Yes, I have several, starting with my grandpa. So I grew up with my grandpa. He lived right next to me. And so I spent a lot of time with him. He was my best friend growing up. And he always would sit with me and teach me things and, you know, from cards to making little, you know, paper art or stuff like that. And so I think that kind of encouraged my critical thinking or like problem solving and stuff like that, trying to figure out how to do things from scratch. And so that would be my first one. And then I had a few in college. So I had a couple professors that were really incredible. One was very supportive, Dr. Pollock. I believe he's retired now. And he was my structural engineering professor, and he was a lot of people's favorite. He was my favorite professor. He was just so supportive of me, so supportive of my career, and it just kind of reinforced my path that I chose. And so I was really grateful for that. And another one was my timber design professor, actually, and Dr. Bender, and he is retired now. So he was really inspiring because every lecture you could just hear, I mean, I took some in-person and online class with him, and actually I think it was just online. Yeah, it was online. So I took 2 courses with him, and you could just hear through this virtual team Zoom meeting how passionate he was about what he did. And it was, you know, it was really inspiring to know that, you know, there are still people that are really passionate about what they do, even though, you know, he was about to retire at the time. So it's, it made me really happy to be in his class. Yeah. And then I had a few at my previous company at Dowell. They are really intelligent people. And so Andy Howe and Eric Vaughn were senior engineers that I worked pretty closely with. And Andy was really supportive, and, you know, he would spend so much time talking with me and going over, you know, my questions, not only at work, but about life. And I think that kind of was really important to me at the time. And Eric is so intelligent, and same thing. He would be pretty patient with me in, you know, reviewing my calculations, making sure I'm doing things right, and answering my questions, and, you know, showing me how to do things. And that is so important to me at the level I'm at. And so all of that time spent on that was just I don't know, I can't express how thankful I am for that time that they gave. And the last one is actually my current manager, Brad Schaefer. He has been basically one of the reasons that I've gained a lot of my confidence in my calculations, in my day-to-day work, and kind of helped me. I struggled a little bit with imposter syndrome, not a little bit, a lot. And so he kind of helped get me out of some of those feelings of, not being good enough or not knowing enough, stuff like that. So for that, I am forever grateful. So yeah. So anyway, so I have a lot of mentors to be really grateful for right now. So.
Yeah. It sounds like you've surrounded yourself with some good people, which is awesome and so critical when you're kind of starting out in your career and figuring things out. I was going to say with Dr. Bender, that's interesting that you had him as a professor, because one of the things I do for Simpson is I go around and talk about how to build a code compliant deck with a few other Simpson colleagues. That's like one of the things we do. And I always reference him in my workshops because there's a YouTube video that I saw where he does this like little video where he shows his students kind of just like swaying back and forth on a deck that they built that's really short off the ground to show how easily it can pull off of the house. Do you know what I'm talking about? Have you seen that?
Oh my gosh. Maybe.
Anyway, I just thought it was such a great way to demonstrate like how little effort it takes to put a lateral load on a deck. It really, I think when people watch that, it kind of hits home, because when you're out on a deck, you're kind of like hanging out and maybe partying or dancing or whatever people do.
Yeah.
But anyway, so it's interesting you actually had him as a professor. I've never met him, but I do like that one video that he has out. So very cool.
Yeah, he's one of my favorite professors as well. Yeah, he's great.
What about as someone who's like eager to learn and eager to grow, what are some skills that you're currently working on, and like what are you trying to develop right now in your career?
Well, I'd like to start by saying there's nothing I'm not hoping to develop right now. I feel like there is so much to learn out there. I'll never stop learning new things. But one of my bigger focuses right now is on substructure design. And I think that also kind of goes right along with seismic design, considering I'm located on the West Coast. And so those are my two main focuses right now. And yeah, because I've already done quite a bit of superstructure design, and most of it is concrete around here, so it's pretty straightforward. So I feel pretty comfortable with that, but I'm definitely hoping to do some more substructure design soon.
So help me out here. What's the difference between superstructure and substructure?
Okay, so substructure is typically your foundation, your columns, and usually your cross beams. And then superstructure is everything above that. So typically your girders, your deck, and diaphragms. And that's like your typical standard bridge, I'd say.
Okay.
Yeah.
I just want to I thought it was that what it was, but I just want to like double check.
Yeah.
So trying to like get more experience working on some substructures and constantly just always trying to learn, which is such an amazing quality for an engineer, because like we just talked about, like this profession is ever changing. So that's a great quality to have.
Yeah. Yeah. And I just have so much to learn about new standards too. And I'm always learning about new sections of AASHTO, and yeah, there's a lot out there. And I feel like the seismic design is such a big thing, and that one is, changes every second of the day, it feels like. So yeah.
Totally. What about, can you tell our listeners a little bit about, you had you'd mentioned earlier when we were chatting offline that your company is looking to hire and you're looking for a senior bridge engineer. What do you guys like when you're hiring for that? What are you looking for? What are the qualities? Like, how do you guys pick a candidate for that type of role?
So I haven't been involved in the interview process other than my interview that I had with the company. But mainly, I would say our office in Seattle is looking for a hybrid and somebody who's looking for a hybrid role. We have a pretty decent sized team who we're looking for more of a technical leader to come in and help, mentor all of us. And basically we have a really good team. We all get along really well together and we work really well together. So mostly looking for somebody who kind of like easily will mesh with everyone and willing to mentor all of us and just, share all the knowledge they can. And so I think the biggest thing is that they are able to work well with everyone that we have so far.
In terms of like their expertise, though, you're looking for someone who has like bridge design experience and is like technically like very like advanced in that area.
Yes. So in Washington, you need your SE license to stamp bridge plans. So we're also looking for an SE, somebody who has their SE, not necessarily in Washington, but is able to obtain it in Washington. So that is another important piece of the role. And somebody who's willing to, commute to the office is also a big thing. We are very much an in-person team. We like to collaborate in the office together, and it works really well. So
awesome. So you mentioned that made me think of something else. You mentioned you have to have your SE to stamp a bridge in Washington. What do you have right now? Do you have your PE? And are you like working on your SE, or how are you doing that?
I am still in EIT, so I am currently studying for the PE exam. I am eligible to register for a PE next January, or the coming January. So I still have a little bit ways to go in terms of experience before I get my PE.
What is the requirement in Washington? How long? Because you got your master's too, right?
Yes. So my master's counts as 1 year. And then, so I'm coming up on 3 years of industry experience. So I think total is 4 years.
Okay. Interesting. It's been a long time since I tested for that. I don't remember what it is.
It's also online. The exam is online now. So that part
is all multiple choice. Is it all multiple choice now?
I think so. Some of them are like fill in, maybe.
Okay.
Yeah.
And does Washington just do the NCSEA test, like the national test, or do you guys also have your own state test that you have to pass? Like in California, we have to take the national exam, and then we also have to take seismic, and we have to take surveying. So it's like 3 tests, but seismic and surveying are specific to California. What is it in Washington? Do they have something like that?
No, we just have to take the national one.
National.
Yeah.
Okay. Interesting. Well, good luck. I hope that goes well.
Thank you.
What about, so final piece of advice. We ask all of our guests this, but what advice would you give to a younger person that is maybe aspiring to be an engineer or looking, maybe interested in bridge design or, somewhere in there? Like what would be your advice to those individuals?
Oh my gosh, where do I start? I think one of the biggest things is to find a team that works for you. That is really important because you want to feel comfortable on a daily basis when you're sitting down to work. You want to feel comfortable to perform at your best, or you want to be able to share your ideas with people you're comfortable sharing your ideas with. That's so important. So I know this isn't specific to bridge design also, but I think that is one thing that made me kind of come out of this shell that I had for a while, where I had, not very much confidence. And so once I was kind of with a team that supports me and I'm comfortable with them, I can talk to them, I can share any ideas, no matter how small or silly they might seem, I feel comfortable sharing them, and you never know when they're going to turn into something. So that is the most important part to me. So I highly recommend being patient, trying to find the people that work for you. And yeah, just another thing that's played a big role in my life is mentors. So making sure that wherever you end up in bridge design, you have a mentor that you work really well with. And usually they're not too hard to find, but it's also an important piece of bridge design.
Yeah. I think that's another thing that we always have to remind ourselves, because I've been in this career a little bit longer than you, but I had people early on in my career, still in my career, that make a big impact on kind of how I picture my trajectory and my goals and different things like that, but also then remembering the significance of that and how it played out in our lives. And then maybe after you get your PE or a little bit further in, you're going to turn around and be like, hey, who could I mentor? And hey, who could I inspire? Who could I, have these conversations with that make them feel like they belong and they're going to do a good job and they have so much potential too,
Yeah, exactly. I've already been kind of answering questions, here and there to some of the younger people, even than me. And I really enjoy that too. I really do. So
yeah. I remember the first time I was asked to be on it was like a mentoring thing, a mentoring session or whatever. And I was asked to participate, and it was funny because I was being asked to participate as a mentor, not a mentee. And at the time I was like, it was a while ago, and I was like, wait, what? I'm still the mentee. I don't understand why you're putting me on the other end of on the other side of the table. So yeah, it's a transition that you have to kind of make to help bring up that next generation of engineers that are coming in,
Definitely. Yeah. I'm happy to share everything I've learned so far, even though it's limited, but yeah, it was kind of a weird point when I came to AECOM and there was younger people than me being hired. And I was like, oh, this is so exciting for me. I can't wait to be a mentor too. All the while I've got all these other mentors helping me.
Yeah, it's awesome. It's awesome. All right. Well, I don't have any more questions for today, Brianne. So thank you so much for coming and chatting with me. And I really appreciated all your insights and expertise on bridge design. And it was a pleasure having you on the podcast.
Of course. Thank you so much for having me.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.